Hello, welcome to video number 7 in the FUME tutorial series, and this time we're going to take a deeper dive into the structure of a complex or a more complex FUME expression. Up until now we've done some pretty simple mappings using the flash syntax, but there are many scenarios where we are going to need a little bit more than that. So let's start by understanding what the FUME mapping language is based on. So the FUME mapping language is actually a superset of the JSONATA expression language, and the JSONATA itself is a superset of the JSON data structure. So JSON is based on several data types. We have the string data type, which is anything inside quotes. So when we say that JSONATA is a superset of JSON, this means that each JSON value is also a valid JSONATA expression. So when we say that the FUME mapping language is a superset of JSONATA, that means that JSON value is also a valid FUME expression. So you can, in the most basic scenario, you can actually use just a fixed JSON as a valid FUME expression. So the string is one of the data types. We also have null, which is also a valid JSON value. Of course, we have numbers, and we have arrays that can hold any of those other data types, a string and a number, for example. We also have a boolean, so I can put here true. Of course, I can also put false. So as you can see, we can construct any JSON, and whether it's going to have fixed values or expressions, this will be evaluated according to the basic structure of the expression. So if I just replace one of these with an expression, for example, this function that gives me the current date time, then in the output I have the structure that I created, whereas that expression is replaced with the result of the expression. Of course, another data type is the object, which is a set of keys and values. So as you can see, you can use just JSON as the basis for a mapping and replace any key or any value with an expression. Now, what JSONATA also allows you to do is combine several expressions. So for example, if I want to take this data that I have here, as you can see, this is based on the previous example of the patient, but this time the structure is an array of objects. Each one has a code and a value. If I want to transform this into an object with a key and a value, and then use it in a flash mapping, that would mean I have two stages. The first stage transforms this JSON. The second stage uses that the result of this transformation as an input for the flash script. So just so you can see, I will first show you how I can also use this structure to create the patient, but you will see the reason why it is probably wiser to do that first transformation stage and then create the patient. So if I want to use it like that, as is, I have this flash template. Let's select one of those fields, for example, the birth date, and try to take the value. So of course it's possible. That would be the data, the name of the array. I will filter it according to the code that equals birth date. It would look like that. And I will take the value. And there we go. And let's also take the first name into name. Data where code equals first name. Let's take the value. So there you go. So I can do that, but there are two problems with this approach. First problem, maybe the filters are going to be a little bit more complex and the mapping will be a little bit hard to read. Second problem is performance. In this fashion, what actually is happening in the backend is that we scan this array every time. For each field, we rescan this array to search for the corresponding object with the code that equals to what we want. And performance-wise, that might not be the best way to do it. A better way to do it is to transform this thing into an object with keys and values and then use those keys in the Flash script. So in order to do that, I will need to combine a first stage, a first transformation stage that will transform this into an object with a key that corresponds to the code and the value. And the next stage will be the Flash script. So in order to do that, I will use a block. A block is using parentheses. We can put inside each block several expressions, and what the block will evaluate to is the result of the last expression in the block. So the last expression in our block will be that Flash script. We'll get right to it, but the first expression in the block will be the transformation of the JSON into a key value object. So if let's start by just taking data. This will result in the value of data, which is the array itself. And one of the tools that JSONata gives us is the object constructor. And when we use the object constructor like this, we can define an expression for the key. That would be the code. And the value would be the value. There you go. Now I have an object that has keys and values instead of an array of codes and values. Now, in order to use that in a subsequent expression, I will need to store it in a variable. So let's just say that that variable's name will be var, and this operator tells FUME to put the output of this expression into this variable. When I want to write another expression, I will need to separate the expressions with a semicolon. So that would be the end of this expression, and now I can start a new one. So just so you can see, I can just use var and say give me var .mrn, for example. So there you go. So if I want to put a Flash script here, I can use var and say on the context of var, open a new block, and inside that block we'll put a Flash script, the template. So this time, instead of opening the template, I will use this button that will insert it where the cursor is. So now we have a Flash script inside a block. That block's context is var, which is an object which is based on this input, but it has been transformed. So instead of search in the array for each field, we have a key. So now, if I go to the birth date, by the way, another cool feature here in the designer is this, that closes everything, and then we can open what we want. So there we have the birth date, and now the birth date can just be equal to birth date. So now the Flash script is going to be easier to read, and the performance of this mapping will be significantly better than if we just rescan the array for each data element. Let's take another field, first name. Put it here. There you go. So this is the, let's call it the anatomy of a Flash script. So the basis is JSONADA. What you see here is classic JSONADA. FUME adds the possibility of having a block with a Flash script. And of course, all of the FHIR functions are also specifically a feature of FUME. So for example, if I want to do the search for this patient, the syntax is based on the JSONADA, but this search function is a function that is only available in FUME. So another use for the parenthesis block is to override the order of operators. So for example, if I have an expression that is 1 plus 2 times 3, I have here now 7, I can also say explicitly that I want this 1 plus 2 to be performed, and only then the multiplication by 3. So without this, the result is 7, and with this, the result is 9. So this is, I guess, the basic structure. This is something that can help you create some more complex expressions. And just remember that the more complex expressions, you should probably store them in variables and then reuse them. It will make everything more readable. And when you want to make things even more readable, remember the comments. So in the designer, there's a shortcut. You can do Control/, and if I have this string here and I'll do Control/, it will become a comment. So you can also use comments, and you should use comments when you create those more complex scripts, and just to document the logic and the reason for doing each step. And I guess that would be it for this video. Thank you, and see you next time.